Now over to my Supabase accounts, I've already created a project called prod rag. I want to go to my storage and I will create a new bucket. I will name my bucket documents, and I need to enable public bucket to make sure that my agent's users will have a read access to the files that I'm going to store in my buckets. Let's create that. Let's go to documents, and then let's start uploading our files. Let's select these two. I have electronic store FAQ and store data protection policy. The next thing that I want to do is to export these files over to n8n for further processing. Let's head over to n8n, and then let's select trigger manually as our trigger node. And I want to use HTTP request node to start exporting my files. I will select post as my method, and over or under URL, I need to go back to Supabase and select my URL by going to project settings, selecting data API, and copying my project URL. I'm going back to n8n and paste it over here. And I need to do a few more things, such as I need to add storage v1 object lists and the name of my bucket, which is documents. Under authentication, I'm going to select predefined credential type. I'm going to select Supabase, and then I'm going to select the proper account or the correct account. I'm going to send body, and I'm going to use JSON, and I will start creating my parameter, which is limit, say 100. You can always adjust this. If you have more than 100 documents, then you can do so. If you have lower than 100, you can do that as well. And offset. And we have prefix. I'm not gonna use any prefix. So let's just use empty and sort by. We have two properties over here. Let's use column name and the order. I will use ascending order. And if you're wondering where I got this specific parameter, it's provided by Supabase, and you can check them out in the Supabase repo. Let's rename our node. By the way, it's always a good practice to do that. Let's say pull files from Supabase. Then let's execute our node. Now we were able to pull our files. We have two items. We have the name over here, which is electronics store FAQ. Now let's add another HTTP. And this time we want to download the files. Method is get the URL. I'll just head back to my previous node, copy my URL, paste it over here. But instead of lists, I'm going to use public. And under option, I'm going to select response. I'm going to select file. And the output is data. Let's execute. Let's just double check. We actually forgot to drag and drop the name of the file. So let's do that by doing this. Let's execute the node. Now we have downloaded both files. Let's rename this once more. Let's say download files. And my next node should be extract from file. We need to extract the texts from our PDF files. And let's execute. Now we have the texts over here. My next node will be storing my data and my chunks in my Supabase vector store. I will select add documents in the vector store. I will select the proper account. And over here, as you can see, I have an empty list. That means I need to head back to Supabase and create a table where my embedding and my chunk data will live in. So let's do that by heading over to Supabase. Let's go to SQL editor. Now I've already prepared this query over here. We want to enable our extension, which is of vector type. We want to store the vector embeddings in a specific column within our table. So the table that I'm creating is documents with the following columns. We have ID, which is a primary key, the contents, which is the actual text chunks, the metadata, the embedding vector, which is what our embedder will create, and the timestamp. Additionally, I want to create an index that will assist in the fast search of our query. If I don't create an index, that means every query will have to go through each of the rows or records in our table, which makes it longer for our agent to respond to a specific query. Now let's run this. Perfect. Now let's go back to n8n and let's refresh lists. Now we can see the table. Let's click documents and let's add our embedder. Let's use text embedding ADA002. This is using 1536 dimensions. Over here, let's select data loader. And this time I want to add more or a couple of properties in my metadata. Those are my file name, which is coming from the downloads files. There you go. And my file URL. And to do that, I need to copy my URL over here. Paste it here, but I need to replace this with the correct one. Let's head over to downloads and then paste it over here. Now I have additional two metadata. Now let's execute this node and see what's in our table. Let's go to table editor, select documents. Now we have this. We have these columns, ID, content, which is the text chunks. We also have the metadata, the embedding, and the timestamp. And over to a metadata, we can see the file URL and also the file name. Now let's start creating our agent. Let's select chat as our trigger. Let's create an agent. Let's add a system message. And I've already prepared a system message over here with this specific instruction saying that there is a citation format and asking the agent that it must cite every claim using the format below. Also, I'm going to use my Supabase vector store as my tool. Let's get a description. Let's select the correct account, JoeDev. The table name is documents. And the chat model, let's just use GPT-4. But we're not yet done. We need to, well, first we need to add our embedder. Text embedding ADA002. But this will, we should be able, or we should run a specific query to actually do the semantic search. And I've actually prepared a query over here that does that, this specific query that says, creates a function called semantic search with the following parameters: the query embedding, which is the vector from the query, the match count, or the top 5 most relevant chunks. We need to do a filter as well as part of the parameter. And this will return a table with the following properties: the ID, the content, the metadata, and similarity. Similarity being 0 to 1, and the closer the value is to 0, the most relevant the chunk is. Let's run our query. Now select or copy the name of the function. Let's head back to n8n and paste the query name or the function name over here. Now let's start chatting. Let's ask, how can I pay for my orders? Now, as you can see, it responded well. You can pay for your orders securely at checkout on the website, etc., with this specific source. And if I click this link over here, or this URL over here, it should bring me to the specific document that the response is referring to. Pretty nice. But what we have at the moment is a stateless agent. It does not have a memory. And if I ask it, say, tell me more, it wouldn't be able to respond properly because it does not have a context from the previous interaction. So let's click memory, select Postgres chat memory, and select the proper account. This is going to ask for a specific table where the chat history should live in or should be saved. Now, to do that, we need to create another table in Supabase and execute a specific query that I've created. Let's run this specific query. This is called n8n chat histories with the following columns: ID, session ID, message, created at, and also we want to add an index that will support for a fast search for this specific table. Now let's run this. Let's head back to n8n and copy n8n chat histories. Now let's start chatting. So let's say, what are the payment methods? So it's referencing to a specific file or to the correct file. Do you do refunds? Now, this is a question that I'm going to ask as a follow-up question just to make sure that it's going to reference from the previous interaction. So let's say, tell me more about it. Now, there you go. So the refund policy states that the most items may be returned within 30 days. So now to make this live, we need to publish our workflow. Let's click publish. And in chat, we need to make chat publicly available. Copy the URL. And we have our chat interface. Let's ask it one more time. How do I make payment? Now it's referencing to our file. There you go.